Welcome to AP Environmental Science. In this video, we are going to talk a little bit about atmospheric carbon dioxide and particulate matter. Keep in mind, we've discussed some of the anthropogenic or human-caused sources of carbon dioxide already in this course, and those are particularly from burning fossil fuels, industrial processes, and deforestation. Now, there are also natural sources of carbon dioxide. And I want you to think back to the carbon cycle and many of the processes that are involved in the carbon cycle. Some of these include respiration, decomposition, volcanic eruptions, non-human caused wildfires or those small, quick burning ground level fires, and that process of ocean exchange and outgassing. These are all natural sources that add carbon dioxide to the atmosphere, and they tend to do this at a rate that can be naturally removed from the atmosphere. And this keeps the amount of carbon in the atmosphere relatively stable. However, when we're adding in all these human processes, things get a little wonky. So again, carbon dioxide is a natural process, and there are natural sources that emit carbon dioxide and sinks that remove carbon dioxide from the atmosphere. Now, burning fossil fuels is adding carbon dioxide to the atmosphere faster than these natural processes can remove carbon dioxide from the atmosphere. And humans haven't really found a way to remove that excess carbon dioxide from the atmosphere other than just encouraging those processes that plants already do that remove that carbon dioxide. So this extras carbon dioxide, that's going to disrupt ecosystems, it's going to disrupt human health, and it's going to disrupt the economy. As we'll discuss later on in this course, we'll talk about how carbon dioxide acts as a greenhouse layer and helps to trap heat towards the earth, and this excess carbon dioxide is actually an atmospheric pollutant. Now, it was not regulated early on with the original 6 criteria air pollutants. In fact, it wasn't until the 1990s that it was considered an air pollutant by the EPA. Again, I want you to look at this diagram. This, I think, is a good summary to help you understand how there are natural processes that add and remove carbon from the atmosphere at pretty much the same rate, and those are both happening on land and in the ocean. However, humans are accelerating the input of carbon into the atmosphere, and they're not really doing anything to remove that added carbon dioxide from the atmosphere. So this is causing there to be more and more and more carbon dioxide in the atmosphere. The other pollutant that I want to talk about in this video is particulate matter. Now, particulate matter is also written PM, and you will see PM 10 and PM 2.5. This particulate matter can be solid or liquid particles that are small enough to be inhaled, and based off of their size, they can do various levels of damage. Now, PM 10 is between 2.5 and 10 microns in diameter, so these are a little bit bigger, and these tend to impact the upper respiratory system. And that's because they're a bit larger and they're not able to move as deep into the lungs. PM 2.5 is much more dangerous, and these are less than 2.5 microns in diameter. So these are able to go deep into the lungs, and they impact your ability to breathe and your ability for your body to exchange that oxygen gas with the carbon dioxide in your blood in the alveoli of your lungs. Now, there are anthropogenic sources of particulate matter, and we've talked about these again throughout this course, from fossil fuel combustion, industry, human-caused wildfires, home fireplaces, mining, and agriculture all are emitting dust and fine particles to the atmosphere. But again, there are natural sources. These natural sources include pollen, bacteria, dust, volcanic ash or volcanic dust, wildfires, sea salt, and airborne soil from wind blowing across dry soil. These all have those same impacts on human health as anthropogenic particulate matter. These human health impacts, particularly of that PM 2.5, include eye irritation, sneezing, runny nose, cough, pneumonia, bronchitis, asthma, and these can even lead to cancer. Again, the size of the particle matters. These larger particles are not able to move as deep into your body, whereas the smaller particles and those ultrafine PM.1 are actually able to get into your bloodstream, and that's pretty dangerous. Now, in summary, you should be able to describe some anthropogenic and natural sources of both carbon dioxide and particulate matter. You should be able to explain how carbon cycles naturally in the carbon cycle and how humans have disrupted that natural cycling. You should also be able to briefly describe some of the serious health consequences of exposure to fine particulate matter. Please leave me your questions here at the end, and I hope that as you watch this video, you were able to learn something.